Hey everyone, my name's Luke Gravett. I'm an Associate FX Supervisor down at Animal Logic in Sydney. And today I'm going to give you a kind of brief overview of our use of Solaris in production and how it went. So just a quick disclaimer before I start. We were actually working on a very early version of Solaris in Houdini 17.5. The guys at SideFX were nice enough to let us play with it. So workflows and things have changed since the kind of recordings that you see here. I will try my best to call them out as I go along. So hopefully you'll see where things have changed and what's different between the two versions. As it says here, we were very keen to get stuck in. So what is it that I'm actually going to be talking about throughout this sort of presentation? So the first thing is, why did we actually need to change our pipeline? Were we just doing it for the fun of it, or was there a specific reason for it? Because Solaris is quite a big uptaking, especially when it's on a very beta version, a very, very early version of Solaris. So it was a fairly big kind of decision to make. So was there any reasons for that? The next thing we'll look at is what were the requirements? This talk is specific towards effects and character effects, as we are the kind of departments in Animal Logic that work solely in Houdini. We import and export all of our data through Houdini and also do rendering. So what were our requirements for the departments to make sure that we could work in the same way as we previously have done with this new workflow that we were developing? And then what was our approach? How did we look at it? Obviously, like I've said before, being in a very early version, we really needed to consider that artists don't necessarily know what this is, have never really seen it before, so how did we kind of approach that problem? And then a bit of a retrospective on, okay, how did it go, what have we learned, and what are we going to be looking at doing in the future? So let's get stuck in. So some context. Why is it that we actually decided to make a change? And as it says here, it's all about that USD. So for most people have probably heard the buzzword, but it's Pixar's universal scene description. And as a studio, we made the shift to USD. So our pipeline is fully USD based. Our scene descriptions, our geometry data, everything that flows through from upstream to us and down to lighting is all USD based. So all the assets we now produce produced in pure USD formats. So we really needed to be able to work with this data. So let's break down kind of what exactly were the requirements for our department. And the first and most simply is to import a USD scene into Houdini and be able to work with it. So here is our test scene. As you can see, the nice crag, courtesy of SideFX asset. And we've got some trees and we've got some buildings and stuff that was just created from other departments. And we needed to be able to make sure that we could bring this in because all of this data you see here was in USD format. So importing into the scene was very important for us. The next thing was manipulating and overriding. So this was the ability to take something that was already existing in a scene and override it. So basically we wanted to be able to say, hey, look, I want that building in the background, I want that tree in the background, and take it over. So that's exactly what I've done here. You can see that I've just taken over, and don't ask me why the timings are so, his magical hammer destroys those two buildings, but it is the way it is. So that was one of our big requirements for our character effects departments, where we needed to take over fur, cloth for productions that we were working on at the time. The next thing is obviously creating new effects, and as a department this is probably the biggest realm of ours. Is being able to apply new things to the hierarchy, new objects into the scene without really the artist having to worry about this too much. So again, just a quick example of here, this is probably my finest effects work I have ever done in all of the 6 years I've worked in it, but some beautiful lightning that comes out when he hits down. And then the final one was create instances for crowds and things like that. So we needed to be able to have offsets and all sorts going on. So again, another wonderful piece of animation of mine. But it's just offsetting random crowds, being able to instance them on, including static instances as well. How do we do that? How's that represented in USD? And how can we manipulate that in Solaris and the LOPS world? So I think it's important to kind of go over what our options were because it really helped drive why we made the decisions that we did. So the first one is, for anyone who doesn't know, Pixar's Houdini plugins. So as part of USD and as part of the open source GitHub page, the guys at Pixar actually wrote a few plugins for Houdini specifically. The great things about it was that it was already built. It was developed by Pixar, which obviously meant it had a very, very tight coupling with USD, required kind of us not to have to touch it too much. And also the source code was available for us to be able to dive in there and see what was going on and how they did it. Disadvantages were that it was still a bit of a black box. Although we had access to the code, it would then require us to get R&D and TD development time and research development time into actually kind of manipulating and making tools that were flexible enough and had enough functionality for us to be able to actually work with it. And that was a big balancing act for us. Was obviously we're not a massive TD department for the effects and character effects guys, so we needed to be able to develop something pretty quickly. The next step was write custom tools, right? And a lot of obviously the great things is it gives you complete control. You can do what you want. You can create the tools that you want, and obviously you can create specialized interfaces which have very targeted things for your needs and requirements. Big disadvantages, a lot of TD development time that we just didn't have available as resource. Artists have to learn new tools. In Animal, we have a tendency to, as a department, we hire Houdini guys and Houdini artists. So for them to come in and then have to learn all of these new tools is quite a big task. And then there's the constant need to keep it up to date. Obviously, USD is still developing and changing very rapidly. And as a company, if you're writing custom tools, trying to keep it up to date is, again, a lot of resources and a lot of time. So, I mean, that kind of leads us on to the inevitable end of this, which you all know is Solaris. So, yeah, the guys at SideFX were like, heard we were doing this, and they're like, oh, look, we've got an early version of this new thing that we're writing, and we'd love you guys to take a look. So they dangled the carrot, and we kind of had to take the bite, as it were. So just a quick bit of context for anyone who doesn't know what Solaris is. It's a completely new context inside of Houdini called LOPS. Under the hood, it is actually creating and manipulating USD data. So it's not doing any custom stuff. It is actually writing and running pure USD code. So it allows you to manipulate at a very low level and a very high level USD-based information. And this can be used for layout, lighting, scene constructions, effects destruction, it can be used for a lot of things, and it is very powerful. So let me just quickly give you a bit of an introduction to what Solaris looks like. Obviously, it's Houdini, so everything is inside of Houdini. But over on the left-hand side here, you have your USD scene graph tree, which shows all of the USD hierarchy and information that exists inside of your scene. Now, this is one of the things the interface does look slightly different in Houdini 18 in terms of there's just a lot of nicer logos, functionality. It's cleaned up a little bit, so it looks a lot tidier and a lot more user-friendly. But so you have the USD scene tree here, which just shows all your hierarchy. The next one is the new USD scene view, and the reason I'm drawing attention to the fact it's new is because it is not the same GL viewport as being used inside of SOPs or object space world. And the reason that's important is because it's actually pure Hydra API and Storm, which is Pixar's GL visualization for USD data. So this is running in that, and the best thing about that is it has features open, which some of you may have seen on the release, which is things like Hydra delegates, so renderers in the viewport, and I'll show you a little bit of that later. So it is a completely new thing. And then over here, obviously, we have our LOP nodes and our network. So let's first take a look at that step of, okay, inputs and importing. So what kind of do our layers look like? So for anyone who doesn't know much about USD, kind of in a very high level wrapper, I thought I'd draw attention to what ours look like. So you can imagine we have different departments here. So in this case, I've got an edit, I've got tracking, I've got layout, and I've got animation. And each one of those is their own department sort of USD file that represents, and that may be broken down into a lot of other USD files, but that represents all of the data coming from those departments that we care about and that we want to use inside of the effects and character effects departments. These then get what's called sublayered in. So sublayer is a USD term that kind of represents a particular composition arc, which is, okay, how do we layer X data onto another piece of data? And sublayers are the simplest. They just say, hey, anything that exists inside of those USD files, just plug straight into this. So our input is just one USD file that is connected to all of the other departments. So we really just interface with one USD file that understands all of the other bits of information that we need and we require to do our effects on. So just a quick bit of context, and the reason why that was important is this is what we used to have. So at Animal Logic, we have what's called an effects container. Just think of it as an effects Houdini digital asset, so it's an effects HDA, and that defines a rig for a particular effect. So whether it's an explosion, whether it's a particular character we're taking over, it is just a rig that has some piece of information in it to create an effect of some kind. So up here we've got the inputs, and this is why I'm kind of drawing attention to this, because before we had lots of different inputs that all came from different we had to process them in different ways, because some of them were alembic, some of them were custom in-house formats. And we had to bring them in from all different locations. Down here, we've obviously got our managers, which is just fairly standard, and then our work area over here. So now this is what our kind of scenes look like. You can now see we just have one input, which is a LOPNet. And all that kind of does is brings in that USD data. Everything else remains fairly similar. So one thing to note is that we are in object space here. We are looking at eventually transitioning over to starting in LOPs, so you're already in that context. But for now, it's you start in object space, you have a LOP network for an input, and then that kind of drives where you start for an artist coming in. So this is our object level kind of input, as it were. So it's called a USD root def. Really just imagine it as an input, and it's actually a very simple node. But it gives us one centralized place to bring in those input files that we can then reference to all of these different effects HDAs and rigs throughout our scene. So you can see here it's literally just an object node that has an input file and a few other configuration files as well. So inside, not really anything special. Up here, we're configuring asset resolvers to make sure we're getting specific information in. We're then literally just importing our input. So this is a sublayer node that refers to that effects input.usda. And then down here, these are all of our outputs that kind of get driven and plugged into our other effects containers. Now, the really nice thing about this workflow is we now have really good and tight integration. You can't quite see it because of the res of the screen, but we have really good and tight integration for versioning of all of our different assets coming in. Now, most people generally won't need to touch it for artists, but for TDs, it's very powerful. We have a custom Python sort of panel called Version Explorer that is integrated purely with our USD scenes. We can come in here, we can swap out versions of different assets. I want a different version of the animation. You can come in here, change it in, and it all filters through and updates live and in your scenes. So that's something that we were never able to do until we kind of got this Solaris USD-based workflow, which is really awesome. So here is kind of where we're actually bringing in our root def. So we're now inside of our effects HDA, and inside of that LOPNet and the input that I showed you, we now just have a fetch node, which is the equivalent of kind of the object merge in SOP space, and obviously the fetch node in ROP networks. It just says, hey, given this other LOP path, just bring in the information that exists in there. So we have this one centralized place that everything hooks into, which is very handy, and it's very kind of tidy for us to work with. So I'm just going to quickly bring up the USD scene graph tree view, and it's only really one thing that I want to draw attention to, and this is this kind column here. So kind is actually a USD tag. It is USD native. As a company, we've added a few extra tags in, so we've got characters and things like that in camera and shot. The only reason I'm really drawing attention to this is because we can use this and leverage this to be able to kind of create custom groups, as it were. They're called collections in USD. So we have a series of default nodes for the artist to kind of, at least as a base level to come in. So over here, you've got your default nodes. So you can see your AL default collections. And on that node, we kind of can reference all of those tags to be able to tag a character. Okay, give me a collection with all the characters. Give me a collection with all the sets. Give me a collection with the camera and things like that. They just make it easier for the artist to kind of grip what they really need to. One thing to note is collections are fairly slow in terms of their performance, just inherently in USD land. But for now, we kind of went with it and said the artist level implications are much greater than kind of having to deal with that speed decrease. We also have another few default nodes there. So we've got like the draw mode, which allows us to swap out to bounding box and things. So if you just watch it through here, you can see that we've got all of our different things, and inside that's just a Houdini digital asset that inside is using pure LOPS nodes. And you can see it just groups all of our collections, so you can come in here and select all of my environments or my sets. And then you've got your draw mode. So in here, we can obviously come in and swap out our bounding box. It's all very quick, it's very efficient, and it allows us to kind of give the artists at least a rough representation of, okay, where do you start? How do you do a few basic things inside of Solaris? Because one thing that is inherently kind of challenging is balancing out the complication of USD, which inherently is quite complicated, and making it kind of an artist-level wrapper where they can interface with it in a very logical and artist-friendly way without having to understand a lot of the USD-based terminology, the USD-based complications with that. And I'll show you a little bit more about how I've wrapped that up as we go along. So this is just a quick one. So to bring it back into SOP land again, which is obviously where you're going to do your simulations, all of your whatever it might be, and this hasn't changed, there is just a LOP import node, which literally just allows you to kind of bring in all your data. So you can see here I'm actually referring to the collections. Houdini has these really nice interfaces that kind of allow you to select different things that exist inside of your USD hierarchy, which is really cool. And then, so you can just bring it in, and then you can see that it's working with packed USD, which is similar to packed primitives, Houdini's native packed primitives. It's just the USD style for that. So once we're kind of narrowed down and at least come up with a solution to, okay, how do we take our imports, the next thing was really thinking about, okay, how do we modify our scene? How are we actually going to apply all of our effects that we've got into this kind of LOPS and into our scene context? And I think it's important to break down kind of our ethos and what were the main things that we really wanted to focus on. The first one was, and this is a big point, is simplify and unify as much as possible. Now, the great thing about USD is it offers a very rich way of being able to layer on top, of being able to override information, of being able to take anything in a hierarchy and kind of doing what you want with it as such. And at Animal previously in our department, we had a lot of different ways to take over a character, a prop, a set, and it got very hard for an artist to be able to know which one to use and when. So that was a big thing for us. The next thing was make it artist-friendly. We needed something that artists were going to be able to come in and go, okay, that kind of makes sense. Yeah, I can do that. I don't have to think about too much, like I said earlier, too much of that complication of kind of the really complicated compositions arcs and how you can layer up, because a lot of people aren't going to understand the terminology. It is a lot of terminology, I have to say. When I was first learning it, it took a while to just sit inside of sort of LOPS, and that's actually how I learned it, was to sit inside of LOPS and just pull around and play around. And then we also wanted to obviously be able to leave it flexible enough that the artists, if they had to, could make changes and could also understand what was going on, because I think it's important. You wrap things up too much and you end up in a realm where artists are so detached from actually what's kind of going on under the hood that they don't understand how to debug things, and you then end up having so much resourcing time on TDs and things like that. So let's take a look at characters, set, and prop effects. So how we took something that already existed in a scene and overrided it. So every single one of the different types, so whether it's instances, effects, or the kind of char prop set workflow, we had a Houdini digital asset for it. In our case, it was always author, what it was, and layer. So in this case, it's author, char prop, set layer. And what this actually did is it looks at SOPs to determine what you worked on in this context. It then correctly sets up all of those complicated things for layering and being able to override certain primitives and stuff in your workflow behind the Houdini digital asset. All the artist really needs to care about is, hey, I want to take over this tree, I want to take over this character, I'm going to do it in SOP land, here's my SOPs, you do the rest. And that is really what it does. It did bring us on to our first point, which is composition arcs. Not so fun. So basically, I'm just going to quickly break this down so that you can see what it is. Let's just say we've got an asset called Curly01 and it's got some geo. Now, the way that we work is actually, that is payloaded. So payload is a particular type of composition arc. Again, I don't want to bombard you with too many different glossary terms from the USD book. But payload is, an important thing to note with payloads is that it allows you to load in the scene composition without loading in the data. So with us, that's important because we have trillions of polygons, we have massive volume sims that for a lighter may not want to load that in to be able to light. with payloads, you can actually turn it off. So when you load in a scene, you can say, hey, don't load any of my payloads, and it will still construct the hierarchy that you saw in that scene graph tree, but it won't load any of the data. So that's an important thing to differentiate. That then gets put behind a variant set. Again, future glossaries, I'm trying to scooch over it. Variant set just allows you to you can see it as a way to swap between different variants, different variations of a particular thing. So in this case, you could have a high-res, mid-res, and low-res geometry of that asset. That then gets sublayered into the department layer. So that's, even me just talking about it, you can see that it can kind of feel quite overwhelming and quite complicated. And it's one thing that when we started, we realized was it's inherently just that way. Unfortunately, that is the way that USD is, but it doesn't have to be. And that's the great thing about sort of Solaris that we found as we went on. So you'll see this is the inside of our author char prop set layer. Now, it looks super, again, it's always like, whoa, what the hell's going on here? But actually, when you break it down, it's not too difficult. And the great thing is this is all hidden away from the artist. They don't need to care about this. So on the left-hand side here, it analyzes the incoming SOPs. So the user puts in their SOP path. It reads that in, and then it basically uses that information to find out where that variant set lives, and then runs a for loop on each of those primitives that have that variant set. And inside here, we import our object. We create a USD clip file, which I'll talk about later. We then payload in our information, and we put it behind the variant set. So you saw from that graph, it's like, okay, there is a node operation for doing each one of these things. And that is what is awesome about Solaris, is that it is so low level at times that you can really delve down and kind of flexibly develop these pipelines very quickly and efficiently. And again, I'm not saying that this is how everyone has to work. This is specific to our sort of company's process and our company's way of constructing the scene in the first place. For a lot of freelance workers or something, they can just come in here and they don't even have to do this. It's just like SOP import, I don't really care where it lives. Here is just an example where we're actually taking it over. So you can see over here, we've got our author char prop set layer. And all I've done here, and oh yeah, over here as well, what this actually does as well under the hood is any inside faces that currently don't exist, we actually put into their own group so we can surface them individually. And all of that sort of stuff happens automatically behind the scenes to the artist. So again, they're just like, hey, I'm working in SOPs here, which you'll see. So I'm in SOP land. Oh, okay, I've done my destruction. I'm going to move it back to the origin, which again is all just Houdini digital assets that we've wrapped up. Then it's like, I'll put my SOP path in, and then inherently it all just works out and calculates the kind of structure for you and just works. So as an artist, it's great because it's just like, okay, I'm going to put that down that node, here's my SOP path, and it does everything else for you. And I think that's the crucial thing for us, was making sure that the artist didn't have to worry about all of that stuff. So we just have a series of nodes, which makes it much more simple to work with. So let's take a look at effects. The main differentiating features, so again, we have our author effects layer. The main differentiating feature here is that we were actually creating new primitives in a hierarchy. So for that, we wanted to make sure that we were creating consistent sort of structures inside of it. Again, artists shouldn't have to know that they want to put it under the effects prim, under this name and this and this and this. Most of the time, especially at least not in big studios, most of the time it's about going, okay, I've got an effect, I just want to put this in the scene. And we kind of wrap up a lot of that things for them so that all of that kind of is much simpler to work on. It's all pre kind of determined. They just have to set a few parameters and it does it all for them in the background. Yeah, so it wraps up all of that complexity. So the author effects layer you can see is a bit simpler. It doesn't have all of the crazy for loops and things like that because again, we're not taking over something that already exists in a scene. So over here, we're importing our objects. This is where we set up all of the naming. And this is actually a Houdini digital asset in itself. And all that does is just sets up all of the naming and structure that the user predetermines on top. Again, you've got your USD clips, and we put it behind our payload again. So that's just to make sure that when lighters load it in, they can kind of go, actually, I just want to turn this off. And I know at this point, a lot of you are probably like, wow, this is quite complicated. And yes, for us it was, but again, that's a bigger studio, and I will show you kind of how you can really quickly, in like freelancers and things like that, can really quickly use this just to do some lighting or look development things. But again, Solaris kind of offers that flexibility to be able to do these really complicated things and then wrap it up, so all of that level of abstraction and complication down there is not really what the artist has to see. So yeah, so you can see here that we've got our author effects layer down here. And then up here, we've got a predefined naming structure. So all of these names and things are set by leads and supervisors. So we found prior to kind of doing this sort of workflow that lighting really like things to be consistent throughout scenes and throughout shots. And we had it where artists would name things completely differently. And you'd get to lighting and all of their wildcards and all of their regex expressions suddenly break because they're like, why is this name water and this name drips? So this just basically allows us to really predefine for artists that they don't have to worry about it. Just go, these are the names, this is the ones, this is what you need to use it for. And again, it constructs that hierarchy for you. So you can't really see it on here. But what it ends up doing is just translating those names that you've defined into a very consistent hierarchy. And again, here's just kind of an example where we've got SOPs, we've got this explosion of lightning coming out. The artist literally just puts in the path, fills out some of the names, and then it comes into the scene and it all gets translated into the hierarchy for you without you really having to think about it or worry about it. And that was a very key thing for us. And then the good thing about that is it's now really easy to layer effects on top and see it in the context of what you're working in, which is another crucial thing, because for us, we will never be able to visualize the entire scene in one go. So here is an example of where I'm actually just bringing in some volumes as well. So yep, volumes are supported. They do require a VDB to be cached out prior, and that is just the way that USD works because it doesn't have its own representation. But you can now see that actually in the scene we have our smoke, and all I've done is applied another node on top of the lightning, so I've still got my lightning in the scene as well. So you can really quickly build up a very complicated scene by just, okay, I've got this effect, I've got this effect, I've got this effect, and you can go up and down the node network and really see how your effects are kind of working together and balancing out. So that was really important for us. So the final node was the author effects instance layer. This one, again, is similar, and everything we tried to keep fairly consistent throughout all of these nodes. It's similar, it creates that consistent name structure, and what it does is actually creates USD point instances, and I use the term fairly logical way because this is one of the workflows that has been massively improved in Houdini 18. When we were using it in 17.5, there wasn't really a tool set, so we had to write our own one. So this, I'll show you it just for interest. But in Houdini 18, it has changed and it's way simpler. So they did an awesome job of wrapping up all of this, again, this kind of extra level of work that we had to do to get it to work. So over here, you can see our scene. I'm just going to quickly go through this. So at the top, our point instance are actually required that we had USD files already pre-baked out. So that isn't the case anymore, and the guys at SideFX, obviously you can use pack primitives and things and it will inherently create the correct structures for you. But we required that you took out USD files first, and what you do is you create a kind of reference of all of those available things that you want to instance on. So it's just that node there creates a point cloud that just has USD file attribute, and that refers to the USD file that we want to instance. So we are in SOP land, and that's one of the other disadvantages. You really have to do prep in SOP and in LOPS, which is not ideal really. Again, for an artist, you kind of just want to say, hey, I just want to instance on this stuff, go. So then we're copying those attributes to the points. We then create random instance offsets. So you can create X number of offsets in an animation cycle and then apply it on, because we only needed basic crowds for the productions that we were working on. So it's just instanced offset crowds that we get crowd cycles in as USD files, and we did some instances, and then you can visualize those instances there. So, and this is just an example of where you can just see the things moving in the scene and with all random offsets. So then importing into LOPS, again, the only thing that was really required extra versus the author effects layer is that we required that instance point cloud. So whenever you created that instance point cloud inside of SOPs, you had to put a path to that, which obviously isn't ideal, and eventually we're kind of migrating over to the new system. And then this just creates some USD-specific data on there. So once we kind of, okay, we're finally in a stage where we can put stuff back in, but what about the look development for actual effects? And this is where some of the real power of Solaris comes in for us. So in Animal Logic, we have our in-house renderer called Glimpse, and the shading language is called Ash. So we actually have a Ash representation of our VOP networks, and we have a node called Ash Material Library, which inside is its own VOP context that has all of the available ASH surfacing nodes that we can then go into. It's a new LOP, and it does replicate the material library node, so we try to keep it as consistent as possible between them, but it basically creates our ASH-specific code with live updates and all of the good stuff that you really want to see on it. So here's an example. So we have a few series of nodes. You can't quite see them all. Some of them are custom Houdini digital assets that are running some Python code, and some of them are, like I say, is the ASH material builder, which is the crucial one. So here's just an example of me actually just creating a shader. So like the material library node, for anyone who has worked with Solaris, you can just put down a node, and what this will do under the hood is actually translating all of our VOP networks into our shader-specific language for Glimpse to be able to read. So this is, you can put down diffuses and all of those. So this context is purely just for ASH. You don't see any of the other nodes that you can use in Houdini. But it's just live updates. You can then come in, promote parameters as you would do in an organic Houdini-esque way. And we're now kind of in a position where we can create materials and we can assign them to our primitives that we want. Again, you've got the really handy USD trees that the Solaris guys have built for you. So, all right, I've created my shaders, but how do I actually render this stuff? Like, what are we doing for that sort of thing? So the first thing is, and I touched on this earlier, is the concept of a Hydra delegate. So in the GL viewport, USD allows actually a plugin of custom renderers. So Solaris guys have been pretty hard at work with the Arnold guys, and I think RenderMan, and I think Redshift as well now. There's a few other integrations for the Hydra delegates. And the really cool thing about that is it is in the viewport. So you can actually see here, we've got our own custom Glimpse delegate that in the viewport we can do very basic stuff with. So at the moment it is not fully fleshed out. We have not finally developed this. Things like materials, things like procedurals still don't come through for us. We are in development of doing things, but I thought it was just important to kind of show you, you can come in here and we're now in a position where we can put down all of our effects and kind of start to develop on them. Yet, okay, we can't really use Glimpse Hydra at the moment, but it is there and it is starting to kind of progress towards this. So we'll eventually be in a state where we can put down all of these effects and then we can come in and just use our Glimpse Hydra delegate, pan around, we can make changes and things, which is really awesome. So in the short term, we have what's called Glimpse View. So this is actually a Python window. And the really nice thing about USD and the really nice thing about Solaris is it was super easy for us to plug in. So our Glimpse window actually plugs directly into the USD data. Again, for any freelance stuff, you don't really need to worry about this because most of the time you're going to be using off-the-shelf renderers, whether it is RenderMan or whether it's like Karma Mantra and things like that when it all comes out. So a lot of this stuff you already get for free in the viewport, but we have our own sort of Glimpse view. And now what it really allows us to do is live and in real time, we can come in here, we can add lights to a scene, we can make changes. And for us, it's been quite amazing to be able to kind of construct an entire scene, render an entire scene, and be able to make these really quick changes in real time. So you can see all of our procedurals and stuff are working now. I can come inside here and I can make changes to my shader. So I'm just plugging in the ability to plug in our display color, which is on the curves, and then you can see kind of things are really starting to be quite dynamic and quite fluid for us, which we never really had this before. And the really nice thing about this is it's now consistent through all the different applications. So the data we spit out can be fed into Maya really easily, or can be fed into our, like a standalone window of this Glimpse view, which is a really powerful thing. So we've done all of our look development, we've done all of our inputs, all of our modifying. The last thing is, okay, exporting the USDs. Now, again, Solaris have you pretty covered, and the SideFX guys have us pretty covered on this thing. There are a few workflows that have changed here as well since H18, and I'll call them out as I go along. But just one thing to note quickly before anything is when you write out a USD file, so they have a ROP USD inside of the LOP network, and when you write it out, Houdini tries to be fairly smart about creating an actual structure for those USD files. And the way it does that is it actually uses the node paths that you're in to be able to split out. And again, this is where that kind of extra level, and most people will never have to worry about this, especially for the kind of freelancers and things where you're not having to write out massive data files and things. You're kind of working inside of Houdini anyway. But it's important for us because we have to make sure that the data we're exporting is fairly consistent to make it easy for us to debug and things like that. So by default, Houdini kind of writes out its own custom paths. Now that's great if you don't really care too much about that consistency. But for us, we needed to really know where we were putting these files and how we were writing them out. Again, luckily, SideFX kind of have you covered. So anywhere you see a save path parameter inside of your thing, it actually allows you to specify a save sort of file path for that given lock node and that given layer. So now instead of it being that object and sphere one, it's now where we specify, which in this case was demo and overpath. And you can now see that I've just got my demo path in there. So you can really quickly and easily kind of tell locks exactly where you want to write out these files. Again, a lot of people don't need to worry about it, but it shows you the flexibility and the power of Solaris in general. So I'll quickly touch on our initial structure. So the first thing was, wherever the main file was, we then had our edit.ustdc, which you can see is compiled. This is where all the heavy data exists, and that then gets payloaded into our kind of lightweight ASCII format that's easy to read and easy to visualize, and it just says, hey, just give me all of that data, whether it's geometries, whether it's volumes, I don't really care, just give it to me. And then that gets sublayered in and fed into our department files. So again, as a department, you saw before, the edit department has a file, layout has a file. We also have a file, so we've got our effects.usda. And then that's just, here's just an example of us kind of doing it inside of those LOP networks that you saw before with the save path. One thing to note is these files can get really big. And this is kind of a big trick is they can use a huge amount of data. So by default, the way that USD works is it obviously compiles it all into one node. It's not frame-based, it is all inside of one file. So when you're writing out these files, it's trying to be really smart and compress data and things like this. This can use huge amounts of memory. We actually capped the farm quite a few times, even with 128 gig machines when we're dealing with 5 to 10 million curves and 200 frame sequences. It gets pretty difficult to work with. So you need to bear that in mind when you're doing stuff. So we really needed to find a way to render per frame. Because that way we could chunk it on the farm without having to worry about it all having to go on one machine, and we could reduce those memory requirements at least on the at least RAM memory requirements. So the solution is something called USD clips. Now USD, again, Pixar being the smart guys that they are, already kind of have us covered here. So USD clips does exactly that. It allows you to specify per frame files that you can then plug into to the rest of the data. So now, instead of the old one, this is what the kind of new file format looks like. So we've got our stage.edit, and you can now see that that big file, the big data file, is all frame padded. So we can now write out that file per frame, which then gets fed into something called the clip template file. That is all USD clips information. You don't really need to worry about that. Then you've got the clip.usda file, which then follows the same structure. Now that's great, and it's all good and well, and it was working for a little bit until we finally realized that actually, even though Pixar is super smart, frames don't interpolate. So with per frame files, and it is something that just to be aware of when you're doing this, if you'd have to ever do this, per frame files don't actually interpolate the data. So when we've got this kind of structure, if you're going at frame 1.5 for motion blur shutters and things, you won't get that translation. It would just be either one or the other. So we had to think of a new way of writing it out. And the way to do that is with basically merging in files, writing out chunked data. So now instead of just having a single frame, we still get the benefit of being able to chunk it on the farm. But now what we end up doing is we have one file that refers to frames 1 to 3 and has an overlay of frame 4. If I was really being pedantic, I'd also have a frame on the other side that would be frame 0 in this case, but that's fine. So you have an overlap here, and then the chunk 4 will basically be run. And then what that means is the frames 1 to 3 are being read from this file, but when the renderer comes to read the motion blur for frame 3 and goes, hey, I want my file forward, it will still correctly interpolate. So that then gets put in there, and that gets put in there, and then that gets fed into the clip.usda. So you can see, again, a lot of buzzwords, a lot of information, but it's just, they're tips and tricks. This was one thing that really caught us out halfway through, where we were like, why aren't we getting motion blur on this? So we managed to, using those save paths and using a few extra things, we ended up in a position where we could still use Solaris in the same way as we had done before, just writing out the data slightly differently. And to create that USD clip file, again, I showed you this a bit earlier, is just you've got the save path there, and we're just creating a new file. And that all gets wrapped up inside of a ROP node that then knows and understands how to write those clips and how to spit out all of that data correctly. So again, for the artist, it's just about, oh man, I don't need to know all of that stuff. I'm just like, here's my node, here's my Houdini digital asset, give me the path, and these are my frame numbers, and I'll write it out. And then that basically led us to wrap up kind of the process to be able to check into our database and things like that into two nodes called a publish CharFX node or the publish FX node. And they just make sure the information's going to the correct slots in Arc, which is our in-house database system, and all of that sort of stuff. And again, because it's a Houdini digital asset, it allowed us to kind of make changes really, really quickly and very efficiently. And again, hides away the complexity, and it still provides enough customization for what the artist needs to use. So that kind of brings me on to the conclusions. So the good, it's awesome for big developed pipelines who are kind of going to USD. We managed to create our pipeline in 2 months, which is pretty insane for FX and CharFX, and prior to that we had to have R&D help. We had to have massive TD teams to make sure that we could do all of this. So the combination of kind of USD and Solaris has been pretty invaluable to us to be able to get that turnaround so quickly. We were on a really tight schedule to get it in charge of production, and we never thought it was even going to work. So somehow we managed to make it work. And I even remember when we spoke to the SideFX guys, they were like, "Are you crazy?" Using that early version, but we managed to make it work, which is pretty awesome, and I've got to thank them for that. So yeah, you have good integration for renderers. So the Hydra Deligate is pretty awesome, and whether that's using RenderMan, whether that's going to be using Karma in the future or anything like that, it's already there, and it kind of is very easy to plug in and set up. And this is kind of a key thing for us, is you're also reading the same information. So, and this is kind of a touching on USD and Solaris, but it's being able to read in the same data, irrespective of whether you're in Maya, whether you're in a custom in-house tool, whether you're in Houdini, is pretty awesome for us, and it's been really helpful to be able to really simplify our processes as much as possible. And yeah, so it's unified our processes, and it's really flexible. Now, sometimes that comes with a trade-off of, okay, the artist, there's an extra level of complexity here that a lot of artists don't need to worry about, and it has been a big challenge of us, is trying to balance out that stuff. But the good thing was that character effects really never had to touch LOPs at all. And obviously they're not doing any look development, the surfaces, all of that, the materials and things are already existing for them. So that was a big thing for us, was we actually managed to really make it solid and make it work efficiently without having to worry too much. So conclusions, not so good. It's a massive work in progress for us. Although I make it out like it worked 100% of the time, it did not. There were use cases, there were things where we had to streamline the process as we went along. There was a lot of head banging to try and get my head around and get our heads around USD in the first place. Again, I want to emphasize that that's generally more specific to big pipelines, is because for most sort of freelance artists or most quick look development, you can go in there. You don't need to care about whether you're payloading, whether you're referencing most of the time. It's just, hey, I want to bring in this effect or this particular thing, make some changes to my shader and see it update, which is what we've tried to wrap up as best as possible for a big pipeline. So there is still a learning curve though, and inherently I think that's an important thing to note, is there probably should be a learning curve, and people probably should have to understand at least the basics of it. And I think that's important again just for general debugging purposes as much as everything else. Otherwise everything ends up falling on our shoulders and our TD shoulders if we have artists who don't necessarily understand it. So although we've wrapped up a lot of that complexity, Solaris, you can dive inside there, it's a node-based workflow, you can stick down a reference node, you can see what it's doing, and you can see how it's writing out file. So there is still a bit of a learning curve, and we really had to balance that out as we went along. And obviously we were working on an early alpha version of Solaris, which was very, very interesting for us, purely down to the fact that there was still features missing. And that was just because they didn't have time to do it really. So they were putting all of their energy into H18, and a massive, massive thank you to the guys at SideFX who managed to backport a lot of stuff for us specifically that we really needed, and I know that they were super on a time crunch. So I want to put a massive thank you out to those guys. So what is it we're looking at kind of doing in the future? So the first thing is upgrading to Houdini 18, obviously. As a department, we're going to have to redo a few of those workflows because things have changed slightly. But it will be redoing it for the better. So the volumes and instance-based workflows that are kind of shown, the instance ones especially, have really been streamlined in Houdini 18. And then also we're going to look at moving our effects HDAs, our effects containers, over to LOPs. Because the cool thing would be is being able to, instead of having it in an object space where they're all insular, is being able to have an effects container chained to an effects container, chained to an effects container, and then all of a sudden you don't have to fetch all of your effects from different locations. All exists inside of that, wrapped up in a really nice location. And then, of course, it's not just me. Special thanks to the R&D guys who massively helped us out with all of kind of the pipeline-based things of getting all of our asset resolutions and things working. The FXTDs guys worked really hard on this. Department supervisor, and then the Glimpse and Ash teams who have been helping us out as we go along to make sure that our integrations are working. We are hiring. If anyone's interested, please go to our website. There's quite a few jobs in Vancouver going at the moment, so hit me up afterwards, or there's an application line there. And yeah, that's pretty much the end of my talk. So any questions?
Thanks. It's kind of a question about the multi-frame clip workflow, and I'm not sure if it's more of a USD question, because Animal's been working with USD in non-Houdini space for a little while.
Correct.
And I hadn't heard of that problem existing before. Is that a Houdini limitation? Is
no,
that a condoned
that
Pixar
they never
workflow?
have to write out quite. We've never hit that memory cap in other departments. It's generally because the effects department is spitting out such large data. I mean, even for render curves on characters and things, they only write out one frame, whereas we're writing out a frame, like obviously a massive chunk of data per frame. So generally, they just never had to really touch that for any of our in-house stuff. And also, a lot of the work that other departments use is procedural based, whereas we're much more of baked information. So the procedurals obviously put all of the information on the render time rather than on the export. And they also do the interpolation differently to USD. But USD inherently, if you try and ask it for an interpolated frame, for specific, and that's only for specific information, yeah, it just doesn't work. We found out the hard way.
Thanks.
Questions? Over there. Mr. Dunleavy.
Hi there.
Yeah, how you go?
Just along the same note, we have kind of seen that USD files do tend to be heavier than native BGO format. Did you guys run into that as well?
I mean, look, the good thing is that we cache out, and I didn't really touch on it here, but obviously in our SOP networks and stuff, we're still caching out BGO files. So the only time we ever write USD files and really read them in is obviously either on the inputs or the export. The inputs actually are much, because we were always working from Alembics or from other in-house formats, and never in BGO anyway, it is much quicker for importing and displaying that scene. In terms of when we're inside of Houdini, we don't really work with, the only USD data we're working with is the inputs and then working in Solaris. We haven't written out any files at that point. So generally, we cache out all of our data still in BGO format and then export in USD and work in LOPs for that.
Okay, so you haven't really done any kind of benchmark tests of BGO against USD?
No, I mean, look, BGO is still more optimized for Houdini. It inherently will be. And if you do a load into kind of SOP land, it probably is a little bit slower. We haven't really had to do much because we kind of already brought in the data. We're not reading files in directly to SOPs. We're already bringing it into LOPs and reading it from there. But caching out large like scenes, we never had to. We just cache out specifically the data that we're working on.
Yeah. Cool, thanks.
No worries.
Other questions? Yeah.
Hey, I was curious about the crowd workflow that you showed, where you had unique time offsets for each agent. how does the, like, as far as I understand it, you've then multiplied your RAM usage by a huge amount. Does USD help with that in any way?
Not really. Look, at the moment, unfortunately, the way that USD does its offsets is and because it's all prim and it's all baked sort of information, it's not procedure, you can't update things. Which is the reason why we need our point clouds, is because we have to give the predefined kind of amount of either offsets or different types of USD. So you still end up running into issues where you have to create, if you've got 60 offsets, you have to create 60 primitives with different offsets. Sure. So we try and be as optimal as possible in terms of reducing that and still managing to feel like it's random and they're not all playing on the same thing.
It's not automatic. You decide what your offsets
will
be in advance.
No, unfortunately not. Inherently, USD is not procedural in that way. So you have to bake everything out and predefine it beforehand. Even because like Pixar even did similar things. They never actually open sourced that piece of information because they never deemed it quite flexible enough to be open source. But they do exactly the same sort of thing where they predetermine the amount of offsets and the amount of types of instances.
Sure.
So yeah, it's just one of those limitations.
Would it be possible to integrate a procedural that did render time skinning to?
Yep, so we are for this project we didn't really have time and there wasn't any need for it, so we were which is why we went with the quicker instancing workflow. There are definitely possibilities, and I know that is on the horizon for the SideFX guys, not in the short term, but in the long term they're definitely looking at that. We are actively looking at it at the moment to see whether there's anything we can do in that realm. But yeah, there's no reason why you couldn't bring in USD skeletons and then get a render time procedural to skin that on.
Nice, thanks.
Any other questions? Yeah.
Is the version control you mentioned early on, is that all part of your ARC asset management system, or is...
Look, I can't talk too much about that stuff.
Yeah.
There's a few different levels of stuff that we're working with, and I can't really touch base on it too much. But it does allow us to be able to select different things, be able to write it. And look, most of the time we really don't need to do that, to be quite honest. It is for our TD-based stuff, and we still use certain things in USD to be able to represent versions as well. So yeah, generally it's a balance and a mix of things.
Does USD have subframe sampling?
USD does. In general, I'm not actually sure. I don't actually know by myself. In terms of, you can definitely, if it's deformed and things like that, you can. And I think you can write out subframes, yes. I think it does have a concept of being able to apply subframes to it.
Any other questions?
There's actually more an answer to the other question. Yes, there definitely is subframe
There you go.
samplings. That's why
So there
we call
definitely
it
is.
time samples as
Yeah.
opposed to frames. They can be at sort of any increment.
There you go.
And also, yes, USD scale is the way to go for crowds in
Yeah,
general.
it definitely is what we're planning on moving towards, for sure.
But yeah, it's very cool stuff.
Other questions?
Hi again. Any particular feelings about USD shade moving forwards?
Look, we're starting to actively look at it. Our in-house render it's difficult because we're trying to balance, like we're trying to see exactly what we lose from moving to USD shade, especially with material bindings and things like that. Glimpse has some very smart and powerful kind of ways to be able to layer materials and things. And we're trying to check that we can sort of represent all of that information and that level of detail inside of USD in general. But we're definitely actively looking into seeing what we can and can't do with it, and we'll go from there once we've done our evaluations. But the good thing is that we've even been able to plug in prototypes for a lot of different systems really quickly with Solaris.
Cool.
Other questions? Going once, going twice. All right, thanks, Luke.
Thanks a lot. Thanks, guys.